See, let me explain one simple pod definition file. So, which is the manifest file. So you can understand how to deploy the objects in Kubernetes. Okay. So basically, this is the file in Kubernetes. We can call it as a manifest file, which is written in YAML format, which tells Kubernetes what object to create and how it should behave. Okay, so in Kubernetes, everything is an object, and this is where configuration starts. Okay, so here there are the first line kind. Kind defines what type of Kubernetes object we are creating. Okay, here the object type is, we can call it as a pod. Okay, a pod is the smallest deployable unit in Kubernetes. Despite of containers being important, Kubernetes never runs containers directly. It always runs them inside the pod. That is where pod becomes the first learning object in the Kubernetes. And the second point is API version, which is V1. So this tells Kubernetes which API version to use. V1 is the stable core API version. Pods belong to the core API group. If the API version is wrong, Kubernetes will reject the file. This is one of the common issues we have seen actually. And then metadata and name is the test pod. Okay. So metadata is the data which describes the object. Name is the unique name of the pod inside a namespace. Here the pod name is test pod we have given. Okay. Basically this name is used when you run the command like kubectl get pods, kubectl describe pod name. So that time we can use this pod name actually. And then we'll discuss labels later. And then spec. Spec means specifications. This is the most important sections. It defines the desired state of the pod. So restart policy never. That means it should not be restarted every time. If you remove this one, if something is happen, automatically the pod will be restart. Okay. And then Kubernetes is a desired state system. So whatever we write here, Kubernetes will try to maintain it. So we have called desired and actual state. So just go through that Kubernetes architecture video, you can come to know. And then we see that containers. So a pod can have one or more containers. All the containers in a pod that share the same network, share the same storage. So this is why pods are used for sidecar patterns. This is where Kubernetes is different from the Docker. Then we'll see here, this is the container. So here we can give the container name. So it indicates a list of the items actually, -. So the name container 01. So this is the container name which is the inside of the pod. This name is used for when fetching the logs actually. And example, if you can see kubectl log test pod -c container 0, we can give it. And we can see here there is a container image. So here we can use the image is the latest Ubuntu, we can use it. This tells Kubernetes which Docker image to use. Ubuntu is pulled from the Docker Hub, and Kubernetes pulled the image using the container runtime. Since Minikube using the Docker Hub via Docker CRI Docker D, Docker handles this part actually. Okay. Then we can use the command. So here this is very important. It overrides the default container command, starts a bash shell, and then runs the infinite loop. We can use while true, and then print the test pod every 8 seconds actually. Basically keeps the container is in running state, help us to test actually for pod creation, logs, container lifecycle, everything should be taken care. Without this the container may exit immediately, so that's what I have given the loop actually. And see here restart policy never. So this defines what happens when the containers stop. Possible values are always, on failure, never. Always is the default. Here Kubernetes will not restart the pod if you put restart policy never. Useful for jobs, debugging, learning. Okay, this is where Kubernetes behavior changes based on the configuration actually. And finally, so these are the resource limits. So we will see later. Okay, so what we will do, we will take this code and we can able to deploy the pod. We will see how to deploy the pod. Then we can use pod.yaml, and here I can paste it whatever I have explained here. Then after that we can deploy kubectl apply -f pod.yaml. Now see, pod is created, kubectl get pods. Now see here, the test pod is running, up and running. After that, if you want to see that pod related information and pod events, kubectl describe, then you can give the pod test pod. See here, you can see all the pod related events here. So when it got scheduled, when it is pulling the image, it got pulled and created the container and start the container actually. So after that, here whatever the configurations here, this is the test pod namespace is the default namespace, and here is the node, same as that control plane, and here is the IP of this pod. And then see here, there is a container. The container name is the container1, and the container ID, and the image which is used for the Ubuntu latest. And these are the resource limits. We'll discuss this later actually. And then we will see, if you want to verify the logs actually, kubectl logs -f test pod -c container01. Okay, so see here, it is printing every 8 seconds, it is printing test pod like that. Here f means it's a flow logs and shows the output of test pod, confirm that container is running correctly or not. Okay, so the summary here is, basically we understood that what is a pod, how YAML file defines the Kubernetes objects, why, because each field is required to deploy the pod, and how kubectl interacts with the cluster. So this is where Kubernetes fundamental starts actually, and once you understand this, eventually deployment, service, Helm becomes easier. So in the next class I will explain step by step for other objects actually. So we will create a couple of other parts with the multiple options. We will see later actually. Okay, so thanks for watching. If any doubts, could you please comment in my channel. One more thing is, we can use kubectl get pods -o. We can use void. It will give that what is the IP address of the pod, in which node it has deployed, and check here ready 1 by 1 means it is up and running actually. Okay, so and one more thing, if you want to check for the status, so without going to the inside of that pod, kubectl then exec, then after that I can use -ps, sorry, we should have to give the pod name exec test pod, then -ps space af. See here, this is the command, this is the thing which is running inside the pod. Then if you want to go to the inside of the pod, -it --bin/bash. So like inside the container, how we go, right? So like this, ps, you can give ps-af. So here we can come to know. So this is the command we have given inside the container. Even we can use watch also, kubectl get pods -watch. So if we enter here, so here we can come to know what pods is going to create, what pods are created successfully, all those things we can come to know actually. So this is about creation part. And if you want to delete this, so kubectl delete -f pod.yaml if we given, so the pod will be deleted successfully. Then after that, again if you can see kubectl get pods, we can come to know. Now see, it got deleted the pod. Then kubectl get parts you can enter, you can come to know nothing is there actually.